Hello everyone, so today we're going to be demonstrating lab 2, which is making a ripple carry adder, and we're going to be showing that on our basis 3 board. So what we have done in Vivado is we have made modules that implement a half adder and a full adder, and then we created this ripple carry adder module which uses the half adder module and the full adder module, and we're going to be using those two. We're going to implement the half adder once, the full adder 3 times, in order to add two 4-bit inputs. And we have these test cases we want to try out. So how this works on our board is these first 4 switches are going to represent the first 4-bit number, which is going to be A. And then these next 4 are going to represent the second 4-bit number, which is going to be B. And then these LEDs are going to represent the sum. However, we have programmed our constraints file so that W18, this LED right here, will not light up. And I can show you that right here. Go to constraints, and we see W18 right there. It is commented out, so we are not going to be using that. Instead, we're going to have U15 to represent our carry out on the final adder, which is also going to be our most significant bit of the sum. So let's go ahead and start with our test cases. So we want A equals 5, B equals 3, and we expect the sum to be 8. So A equals 5, that's just going to be the first switch, not the second, and it's going to be a third. These LEDs light up as these switches go up, which makes sense because we have A plus 0, so we expect A as our output. So now we want B to equal 3. So in order for that to happen, it's just going to be the first 2 switches. So this is good because we see that our binary output is 8. 1, 2, 4, 8. So first test case is confirmed. Let's go ahead and do our second test case where A equals 8 and B equals 9. And we expect the sum to be 17. So if we want A to be 8, 1, 2, 4, 8, flip the 4th switch up. And then if we want B to be 9, it's just going to be the 4th switch up, that one, and it's just going to be the first switch, that one. And we expect the sum to be 17. Now remember, W18 is basically a gap between these first 4 and the last one. So if we have this one represent 1, we have this one represent 1, 2, 4, 8. Skip this one, that's going to be 16. So we have 16 plus 1, which is 17, and that lines up with our test case. So that is all I have for you, and thank you for coming in.